Today we are looking at a new 3D shape, cones. So we are doing volume of cones. Find that page in your note packet. If you don't have a note packet, get this in your learning log. Get your title, volume of cones, and your learning target. I can describe a cone, solve problems involving cones. All right, remember this is a video at any time. You can pause it, rewind to get what you need. Here we go. What is a cone? A cone is a 3D shape with one circular base connected by a curved surface to a single vertex. Okay, so a cylinder had two circular bases, a cone has one. And I bring that up because there actually is a relationship between a cylinder and a cone, as you will see here. A cone is 1/3 the size of a cylinder. So because of that, our formula changes. For volume of a cylinder, it was big B times height. For a cone, we're going to put 1/3 in front of the big B and then multiply that by height because it's 1/3 of the size. So remember, big B stands for area of a base, and the base of our cone is the circle, even though you're probably most likely thinking of ice cream cones. Okay, but yes, that would be the base it would sit on. It can't sit on that vertex. So our big B becomes area of a circle again. So we end up for a cone taking 1/3 times pi times radius squared times height. So we've just added the 1/3 element in front of this to be multiplied by. Remember, for pi, we will be using 3.14, and you can use a calculator for this math as well. Save your rounding for the end. All right, let's look at a couple examples. This first one, we have a cone, and we're going to round our answer to the nearest tenth, and that rounding takes place at the end. So again, we're going to be listing what we know, and then that will help us to substitute into our formula. On this cone, I can see the radius is 3, and that's right here. And then the height, how tall it is 6 inches. So take your formula, 1/3 times pi times radius squared times height. And now we're going to substitute in our knowns. So we know that pi, we're going to use 3.14. Our radius is 3, so we're going to do 3 squared. And our height is 6. All right, there's some math I can do before I hit to my calculator. I'm going to do that exponent. 3 squared, 3 times 3 is 9. Now, with the commutative property, we can multiply in any order and still get the same product. So I see right away, I can take 1/3 of 9. So I'm going to do 1/3 of 9, and then I remove that fraction. 1/3 of 9 is 3. And I can also do my whole number multiplication, my 3 and my 6. 3 times 6 is 18. So it's just less numbers that you're having to put in your calculator, which is good because that gives you less of a chance to type something incorrectly. So we went through from 4 possible different digits to just 2. Now in your calculator, type 3.14 times 18. And I have that as 56 and 52 hundredths. We're asked to round to the nearest tenth. So the 5 is in the tenths place. Look at the 2. That's less than 5. So our final answer is 56 and 5/10 inches cubed. Remember, with volume, it's a 3D shape. So we have the 3 dimensions on our units as well. Let's look at another example. A cone-shaped paper cup is filled with water. You might have seen these at water stations before. The height of the cup is 10 centimeters and the diameter is 8 centimeters. What is the volume of the paper cup? And again, we're going to round to the nearest tenth. All right, so I've already listed my knowns. Diameter is 8, but that doesn't help me. It helps me get the radius though. 8 divided by 2 is 4. So I'm going to be using a radius of 4 and a height of 10. go to your formula, write the formula first without substituting things in so you can see the place where those things go. All right, pi is going to change to 3.14. My radius is 4 squared, and my height is 10. Keep my 1/3 this time because my two whole numbers that I have after squaring the 4, that's 16 and 10. Those are not multiples of 3. Okay, but I can still do 16 times 10 to condense that a little bit. So I'm going to have volume equals 1/3 times 3.14 times 160. Now, here's a trick for doing 1/3 in your calculator. 1/3 is the same as dividing by 3. So you're going to type in your calculator 3.14 times 160 and then divide by 3. And you should get a volume of 167 and 47 hundredths. And rounding to the nearest tenth, that would be 167 and 5 tenths centimeters cubed. Because after the 4 is a 7, and that's bigger than 5. Okay, now we have a level 3 kind of problem where we're looking for a missing dimension. So I'm giving you volume in one of the dimensions. So let's see what we know here. Find the height of the cone if the volume is 29 3/10 feet cubed and the radius is 2 feet. And again, we're going to round to the nearest tenth. All right, so I've listed my knowns on my side. I have the radius. I have the volume. Let me just write my formula so I can see where I'm substituting things in here. Okay, in place of volume goes 29 3/10. So the big V goes away. The 1/3 stays. Pi becomes 3.14. Radius squared is 2 squared. And height's what we're looking for. So height stays in H. All right, let's see here. I can do 2 squared is 4. Now I have that math to do on the right side. So I'm going to, in my calculator, do 3.14 times 4 and then divide by 3. So 3.14 times 4 is 12.56. And divide that by 3, I get 4.19. So 4.19H. I'm going to divide both sides by that coefficient of 4.19. And we'll get our height is equal to approximately 7 feet. All right, so this was a challenging problem, but then look at this one. I'm going to put 2 stars by this one. How do I find the volume of a composite figure? All right, so a composite figure is when you have 2 or more of a 2D or 3D shape put together to make a new shape. And we have a composite solid because it's 3D. So round to the nearest tenth. So the first thing you have to do is identify what shapes you have and then identify what you know. Okay, so on the top we have a cylinder, and that cylinder is sitting on a cone. The cylinder and the cone both have that same circle base. And what we know of that circle base is the diameter is 8. If the diameter is 8, then the radius is 8 divided by 2, which is 4 feet. So that's something that we need. We can see the height of the cylinder is 4. And then we can see the height of the cone is 5. All right, so we have 2 different volumes to calculate here, and then we add them together. Volume of a cylinder, you do pi times radius squared times height. Okay, and then after we calculate that, we're going to add that to volume of a cone, which is 1/3 times pi times radius squared times its height. So we have some different numbers to plug in here. For the cylinder, we're using 3.14. Our radius we said was 4. And the height of that cylinder is also 4. So 3.14 times 16 times 4. 16 times 4 is 64. So in your calculator, you would do 3.14 times 64. So I'm going to write that volume over here because I want to add them vertically. That's 200.96. That's right here. Okay. Now let me do the cone in a different color. So for the cone, we still have 3.14, and our radius squared we already know is 16, so I'm just going to jump to that. And the height for the cone is 5. 16 times 5 is 80. And we're going to do 80 times 3.14 in our calculator, and then we're going to divide that by 3. So the volume of the cone is 83 73/100. So I'm going to put that under here. And then we would add those together to get the total volume of this composite solid. Actually we go right to left, right? So 6 plus 3 is 9. 9 plus 7 is 16. Carry the 1. Decimal point 482. And we're talking about feet cubed. So 284 and 6/900 feet cubed. That would round to the nearest 10th. So we'd actually say 284.7 feet cubed for this composite solid. All right, bring these notes. Get ready to go.